So this video is about writing expressions and equations from words. We're going to break it into two videos because it's going to be so long, I think, but we'll give it a try. I might get it all done in a reasonable time. But as we solve problems in math, we need to be able to convert word problems, real life problems, into expressions and equations so that we can solve the problem. You've learned these words over the years. You probably started them in the third and fourth and fifth and sixth grade, and they didn't mean much now. But as we really, throw these into things, I really need you to know them. So the words for addition, if we need to add something, obviously we might say add or total or sum, SUM. That's a big one. And then combined is another big one. For subtraction, we seldom say subtract when we're doing a problem, but we often say less than or difference. There's one that's not mentioned here, but difference is a big one. For multiply, obviously multiply, but this one down here at the bottom, this of, we might say 20% of 1,000, and it means to multiply. You might say at this rate, times, and so on. Now to divide, you might see the word quotient, and we're going to see that word a lot. I want to point out to you this out of. By putting the word out in front of, well, we get out of, and we need to be dividing for those. So keep these words. They're powerful words. Keep those in mind as we go forward. And Patrick Starr here is going to help us learn about it because you know what? Patrick has the best words, right? Okay. So here we go. First, we're going to start out very simply, and we're going to write some expressions. So again, the word sum means to add. So if you have the sum of 5 and x, then we write very simply 5 plus x. When you use the word sum, you want to write these in order as they appear in the word sentence or the word expression. Now this one is a lot harder and it shows up in a lot of places. This is the one that you're going to make the most mistakes with. 5 less than a number. Often students will write 5 minus x for this one. 5 less than a number. But when you're dealing with subtraction, it matters your order. Now I want you to think about it this way. If I said 5 less than your age, would you say 5 minus 14? No, of course not. You would say 14 minus 5. So we don't say 5 minus x. We say that number that we start with, and we want 5 less than it, so we have to take 5 away from it. So that's the expression that you would write for 5 less than a number. Now I'm going to introduce you to the word is. Is, ladies and gentlemen, means equals in mathematics. So the sum of x and 8 is 14. X and 8 is 14. Simple. Just remember when you see the word is, you're going to put an equal sign. Uh-oh, wait a minute. What did I just say? And then we get to this one. Is less than. Now up here we said that less than means subtraction, but the minute you put an is in front of it, all bets are off and everything changes. Is less than puts us in the realm of an equal, but because it's less than, we go into the inequalities. So when you see is less than, this is what it looks like. The product of x and 9 is less than 25. So product means to multiply. So I'm going to say 9 times x. Notice I put that different. I changed the order because in algebra we write 9x instead of x9. So 9x is less than So we do this. It is less than 25. So when an is with the phrase less than, you've got to do an inequality sign. It might say is less than or equal to, and then we would use that symbol. All right, now we get to of. Of, as we saw in our first slide, means times. 20% of X is 10. How do we write 20% in math? Well, we don't write it with a percent sign. We write it as a decimal. So 0.20 times X, and that's equal to 10, or we might write it as 0.2x is 10. All right, so those are our simple expressions. So now I want you to pause the video and see if you can do these examples. Pause it, and when you come back, I'm going to have the answers. I'm going to work through the answers. All right, you're back. I hope you actually did pause it. I'm going to go through these fairly quickly. The sum of X and 9, sum means I add, that becomes X plus Y. Not 9, but Y, sorry about that. And you're done. The product of E and F. Product means we multiply. These are variables. We don't use a multiplication symbol. We just say E, F. That means E times F. Q less than D. Now this one's a little bit harder because in the other examples we had numbers and it helped us. Notice there is no is less than, it's just Q less than D. Do not use an inequality sign. This is subtraction. So Q less than D means I start with D and I take away Q from it. 5 less than P. Well, that one's easy. P minus 5. Twice a number C. What does twice mean? Twice means we multiply. We multiply by 2, so twice a number C is 2C. The difference of 12 and X. Now this one, because we didn't say less than a number, because we said the difference between two numbers, in cases like this, we do almost like addition and we put them as we read them. The difference of 12 and X. So that one's a little bit sneaky. All right, so let's go down to this one. Let me move my picture up here out of the way. And we're here. Now we're getting to some that are a little bit more complex because they're compound problems. So look at these two. Twice the sum of X and 3 compared to twice X and 3. Because we have this sum of in here, we have to use parentheses. So twice the sum of X and 3. Well, that doesn't mean twice X and then add 3. It means we're going to multiply 2 by the sum of X and 3. So twice the sum of X and 3. Now compare that to twice X and 3. Well, that means twice X and 3. So you really want to keep an eye on this sum of, because that should be a clue that you're going to need some parentheses. All right, let's look at this one. Woodrow's age 7 years ago. Okay, now, at first we might think, well, we need to know, well, how old is Woodrow? We need to know how old he is now to know how old he was 7 years ago, but we don't know. And in algebra, when we don't know, we put a variable. So W. That's how old he is right now. So how old was he 7 years ago? Well, his age right now minus 7. Woodrow's age minus 7. W minus 7. Okay, now this is an interesting problem. It is more complex. The amount of money Della has in cents if she has 6 more dimes than Felix. Well, how many dimes does Felix have? We don't know. So in algebra, when we don't know, what do we write? We write a variable. So we're going to say that Felix has F dimes. Okay, so Della has 6 more dimes than Felix. So let's add 6 to this. But here's the glitch. They didn't ask us how many dimes she has. They asked us how much money she has in cents. How much is a dime worth? How much is 1 dime worth? It's worth 10 cents. So if this that I put in parentheses represents the number of dimes that Della has, well, what's the value of her dimes? We multiply those by 10, but we have to have those in parentheses. All right. So here we're going to get to some expression practice. Again, I want you to pause the video, see what you can do, and then come back and I will work through these. Did you pause it? Please do. Okay, we're back now. Going to work through these. 6 more than a number. Easy. 6 more than a number. I'm just going to say X. 2 less than 5 times a number. 2 less than 5? No. 2 less than 5 times a number. So remember, this is that less than we talked about. So we're going to go back here and put a -2 because I've got to take 2 off of whatever's going on. 2 less than 5 times a number. There we go. Number 3, the product of 4. Okay, whoa. The product. Ooh, that means I'm going to be multiplying 2 things. Okay, let's see what we're multiplying. The product of what 2 things? 4 and the square of a number. 4 times x squared. But remember, in algebra, we don't like writing the multiplication sign. So what we really want to write is 4x squared. Number 4, the quotient. Whoa, what's quotient? Well, we know that quotient is divide. In algebra, we don't use, just like we didn't use multiplication symbols, we don't use division symbols. We use fraction bars. And our fraction bars, we want to keep horizontal. So for this one, I'm going to find some room here. Give me a minute. I'm going to cover this up for a minute just so I have plenty of room. All right, so the quotient of a number squared and 8. So it said the quotient, so I'm going to come over here and put a fraction bar. Now, what 2 things am I dividing? I'm dividing a number squared and 8. So that's what you write for the quotient of a number squared and 8. Number 5, 4 times the sum of a number and 9. Again, I'm going to cover this up so we're not getting confused here. All right, let's do this. 4 times what? 4 times a sum. So I've got to do the sum before I can multiply it by 4. So let's go and see what I'm multiplying. A number and 9. Well, I'm just going to choose the number x, and I'm doing the sum, so I'm going to add, and I'm going to add 9. So that is the sum of x and 9. And now let's do 4 times that and put the 4 out front. A number decreased by 2. Easy one, x minus 2. 5 more than 2 times a number. 5 more than 2? No. 5 more than 2 times a number. 5 more than 2 times some number that we don't know. And in algebra, when we don't know, we put a variable. Twice this is on number 8, twice the sum of 3 and a number. Okay, that should be a flag, the sum of what? 3 and a number. So I'm going to do parentheses, 3 plus a number, and twice the sum of it. And there we go. Patrick found those kind of hard. Okay. So let's keep going. Last page. These get a little more difficult because we're adding in an equal, because now we're doing equalities, we're doing equations. And as much as I hate to do it, I'm going to cover up old SpongeBob here so that I have plenty of room to work. So these are some examples that are going to help you with your work. 3 less than a number is 18. Well, there's that less than. That should be setting off little alarm bells all over the place for you. 3 less than a number. So I'm going to subtract 3 from some number, and it is 18. That's our first equation. Number 2, 1 more than, well, 1 more than what? Twice a number. So 1 more than twice a number is negative 13. So if I literally write down everything I read, I'm going to come out with the correct equation. Let's do number 3. The product of, well, remember, product means I'm going to be multiplying. 8 times a number and 8 is 79. The product of 8 times a number and 8. Whoa, the product of 8 times a number and 8. I think I made a mistake here. Nope, I didn't. The product of 8 times a number and 8 is 79. I multiply these so we end up with 64x is 79. That was a tough one. I'm going to cover this up again. If I'm going too fast, just pause the video to write this. Number 5, 6 times the sum of a number and 9 is 32. 6 times the sum of a number and 9 is 132. Good. Now we get to the hardest one of all. And these are going to be a series of expressions with, and we're going to end in an equation. So number 6 says, let Bonnie's age today, right now, be B. What was her age 6 years ago? Well, if Bonnie is B right now, 6 years ago, she was B minus 6. Then we get to this one. If Clyde is 1 year younger than Bonnie, what is his age now? Well, how old is Bonnie right now? Bonnie is B. He's 1 year younger, so we take a year off of Bonnie. See here, what was Clyde's age 6 years ago? Well, if Clyde is age C today, then how old was he 6 years ago? C minus 6. But wait a minute, let's keep all this in terms of Bonnie's age. Now we know that this right here is Clyde. So what we really could do, instead of saying Clyde, we could say B minus 1, because that's Clyde, that right there's Clyde, minus 6. All right? Which, of course, we can write as 6, I'm sorry, not 6, B minus 7. Then let's get to D. 6 years ago, the sum of their ages was 35. Well, let's come back up here to B. Clyde is B minus 1. So let's write b minus 1 minus 6. That's how old Clyde was 6 years ago. Now we're going to add Bonnie's age 6 years ago. B minus 6. And then today, and if we added those together rather, we would get 35 years. We can simplify this to say b minus 7 plus b minus 6 equals 35. And once again, simplify it one more step and get that 2b, whoops, ran out of space, 2b minus 13 is equal to 35. And if we solve that equation, we will know how old Bonnie is. I hope this is helpful. Come back here, make sure I have no more slides. That's it. I hope that helps you figure out. And I'm going to admit right now that I'm not 100% sure that I got this one right. So really look at that. Think about what I did. And if I messed up that last one, please tell me about it. Thanks so much. I hope this helps you get through turning word problems into expressions and equations. Have a great day.